We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello friends, my name is Khushboo Nilesh Kumar Prajapati. It's a pleasure to meet you. I am from BHULABHAI VANMALIBHAI PATEL Institute of Technology, Diploma Studies UMRAKH, lecturer in Civil Engineering Department. Subject Soil Mechanics, Chapter Permeability and Seepage, Topic FlowNet. Friends, FlowNet is a graphical representation of flow of water through soil mass, and it is very useful to determine uplift pressure, exit gradient and seepage pressure. In today's lecture, I am going to give some important information about FlowNet. So let's get started. Friends, FlowNet is a curvilinear net formed by the combination of flow lines and equipotential lines. In this figure, the blue lines shows the flow lines and red line shows the equipotential lines. Flow lines or streamlines represent the path of flow along which the water will seep through the soil. Equipotential lines are formed by connecting the points of equal total head. Equipotential lines are always perpendicular to flow lines. The space between 2 adjacent equipotential lines represents a drop in head, which is known as potential drop. Construction of FlowNet is often used for solving groundwater flow problems where the geometry makes analytical solution impractical. The FlowNet is an important tool in analyzing 2-dimensional irrotational flow problems. It shows the direction of flow and head at different points. The space between 2 adjacent flow lines and 2 adjacent equipotential line is known as field. Now I am going to share another figure in front of you related to FlowNet. In this figure, a FlowNet is drawn below the dam. Each flow line starts from upstream boundary H1 head. Viscous friction occurs below the dam, which decreases the head. The head becomes H2 at downstream boundary. Now we will discuss some characteristics of FlowNet using this figure. 1 number. Flow lines and equipotential lines in a FlowNet intersect at right angles. 2 number. All fields formed by equipotential lines and flow lines are approximate square. You can see the squares in these figures. Same quantity of flow occurs through each flow channel. Same potential drop occurs between any 2 successive equipotential lines. The smaller the dimension of a field, greater is the hydraulic gradient and also velocity of flow. Now we will discuss some applications of FlowNet. One number, rate of seepage loss, that is Q. The space between two adjacent flow lines is known as flow channel. The flow from one flow channel is delta Q is equal to K into I into A, where K is coefficient of permeability and I is hydraulic gradient. Delta Q is equal to K into delta H upon B, A into 1, where A is width of field, B is length of field, and that is why the field thickness is 1 unit. Now because of the square field, because the field is square, A is equal to B, and that is why delta Q is equal to K into delta H. Suppose the total decrease in head is capital H. Therefore, the H will be H1 minus H2. Delta H is equal to H upon ND, where ND is number of equipotential drop. Say delta Q is equal to K into delta H as equation number 1, and delta H is equal to H upon ND, equation number 2. From equation number 1 and 2, we can conclude that delta Q is equal to K into H upon ND, which is the discharge from one channel. Therefore, the total discharge from the flow net will be Q is equal to NF into delta Q, where NF is equal to number of flow channel. That is why Q is equal to NF into K into H upon ND. Q is equal to K into H into NF upon ND, where NF upon ND is shape factor of no flow net. Number 2, uplift pressure. We can find out uplift pressure using this equation. U is equal to HW into rho W, where U is uplift pressure, HW is piezometric head, that is H minus Z, where H is hydraulic potential at any point under consideration, and Z is position head at that point above datum. Friends, uplift pressure is very important for stability of masonry dam. The weight of dam is in downward direction and the uplift pressure is in upward direction. Therefore, the stability of dam decreases. We can decrease the uplift pressure by constructing a vertical cutoff wall near the upstream base of a dam. Number 3, seepage pressure. We can find out seepage pressure using this equation. PS is equal to H into rho W. The seepage pressure is always in direction of flow. Number 4, exit gradient. The maximum hydraulic gradient at downstream end of flow line is exit gradient. IE is equal to delta H upon L, where delta H is potential drop and L is length of the last field. Now I am going to share a question in front of you, and you have to think the right answer from the option. A flow net is drawn to obtain option number 1, seepage, coefficient of permeability and uplift pressure. Option number 2, coefficient of permeability, uplift pressure and exit gradient. Option number 3, exit gradient, uplift pressure and seepage quantity. Option number 4, exit gradient, seepage and coefficient of permeability. I hope you will get the answer very soon. I hope you get the right answer. Yes, the answer is C, exit gradient, seepage pressure and uplift pressure. I hope you enjoyed this lecture. Thank you for watching. Happy learning.